All right, let's begin our review prior to getting started with this semester. The review deals with Chapter 11 from when you took Business Economics 1 or Business and Social Science Mathematics is the name of the course. And we ended that course with exposure to limits and the idea of the connection of limits with the derivative. So we begin with the understanding of a limit. Limit is the value of an output of a function as x approaches a destination. And on page 585 of our textbook, it stated it in this fashion. Notice that we're talking about a structure and an action, and that the limit symbol is a capital L, a capital L. So we have the groundworks, and now we're going to review some things to create a synapse for you about where we're going to go with this. So this one says, let f be a function and let a and L be real numbers. That means they're not imaginary. They can be fractions, but they are not imaginary. As x values takes values closer and closer, but not equal to a 1 of a on both sides of a, the corresponding values of f of x get closer and closer to, and perhaps equal to, L. So this says that the limit as x approaches some value a from the left of that function equals some L. And then that the limit as x approaches that value from the positive sides is also approaching the same L. Therefore, we can say that a limit exists. The value of f of x can be made as close to L as desired by taking the value of x close enough to a. And that is if we're using a calculator or graph. Right. So then the L is the limit of the function f of x as x approaches a. And this is the structure. All right. Well, let's read on and see what else we can recall. If a limit exists, then there is a value that x approaches. That means it's a y or outcome. It approaches this value as x approaches the given value. Recall that a function can have a removable point, meaning it's a hole in the graph. At that point, that may or may not exist, but is a destination. In other words, that's where it's going or driven to. So the rules of limit are listed here. And I have given you a blank notes for this review found under Bright Space under videos and completed notes so that you can read again all of these limits. The constant means that the limit of a constant is the constant. No, because it doesn't matter. It's a horizontal line. And the limit of a constant and the function rule of a limit is that we have a constant in front of the variable, so it is whatever the k times the outcome of the input of small a into it. The difference, that means you can take them in pieces and still come up with the limit. The product, that means that we can take their individual limits and then multiply them at the end. The division is tricky because the denominator cannot equal 0 at any a. If we substitute a in it, it cannot equal 0. So we have to manipulate that a little bit in order to do it. The polynomial rule for limits is that the p of x is equal, the limit as we approach a of p of x, so the polynomial is all terms with positive exponents, is the value of a in that function. The power rule says we can get the original function value and then raise it to the exponent. And the logarithmic, which is another animal. So we're going to start first with this guy right here. In this case, we're stating that this graph is a function. For every x, there is only one y. So we're going to take the a function first. And it says the limit as x approaches 3 of g of x. All right, because we're going to do it by following. So first we want the limit as x approaches 3 from the negative for that g of x. All right, so we're going, here's 3. We know it's a value. So as we approach from the left, it approaches a limit of 2. Then we're going to do the limit as x approaches 3 from the right for that g of x. All right, so we're going to use a different color here. We're going to use a green. And from the right, it also approaches 2. Then we test it again and say, does f of 3 equal something? And it equals 2, because it is a solid dot. So all of these match. So the limit as x approaches 3 is 2. Now we're going to do the second, the b part. The limit as g of x approaching 5 of g of x. All right. So again, we're going to take it from the left and see what happens. And so we're going to say the limit as x approaches 5 from the left for g of x is, and I'm going to use my red because we're going to from the left to reach 5. And we can see that it is going down to negative 2. Now we're going to do the limit as x approaches 5 from the right for g of x. And we're going to use a different color. Let's go ahead and do the black. And what happens here, from the right, it approaches an open hole, and it is a 3. And the limit to approach, no, sorry about that. We want to drop in to see if it actually exists, right? So we're saying f of 5 equals, and the solid dot is this one, negative 2. They don't match. So therefore, the limit as x approaches 5 does not exist. All right. Well, this is a calculator. So we want to recall how to use our calculator because it is important. So on my syllabus, I required an 83 or 84, preferably an 84. And I spoke to you about getting it on your smartphone. And I hope you've all decided somewhere to get a calculator to do this course. All right. On a calculator, we are finding specific values as it approaches 2, because we want the limit as x approaches 2, but we're looking at it from the left and the right. So we're going to first enter function. All right, so we're going to strike our y equals key, and we're going to clear anything that's in there. And then we're using y1 to enter the function. So it's flashing right there. So we're on y1. So we're going to enter parenthesis second row, second key, which is this key right here. So we're going to enter this because we have to tell it what the numerator is. So it's we're going to do the X key, the up caret. We're going to enter the 3, and then arrow to the right to bring it down from an exponent, minus 2, and then the X key, and we're going to do minus 4 and close parentheses. So we're going to do that part first. Open parenthesis, X variable, second row, second key, up caret, 3, side arrow to bring it back down. And we're going to do minus 2x. X is second row, second key, minus 4, close parenthesis is my numerator. Don't put it in parentheses, it will not work. So we've got that. So now we're going to do the bottom half. So we're going to divide. So we're going to hit our divide key, and we're going to open again with a parenthesis for the denominator. And we're going to go second row, second key, and minus our number 2, and close the parenthesis. So I'm right there. I'm going to hit divide, and then I'm going to open parenthesis, second row, second key, minus 2, close parenthesis. Now this guy right here is critical because it is the denominator. And it has to be enclosed in parentheses. So that makes the denominator. And this part right here, the division, is the fraction bar that we did. All right. So I have it there. And then I'm going to now graph it. To graph it, we're going to start with zoom key, and we're going to choose number 6. Okay, zoom 6. See what? Oh wait, I'm sorry. Zoom 6. Z standard. That means a 10 by 10. Hit that, and it had 6, and it'll graph. Now we can see the graph. Once we see the graph, we want to give it a command. So we've got calculator notes. We got to enter the function. We graph, and now we're going to give a command. So we're going to give it a command on the home screen. And so long we can see the function, we can get all the values we need because they're 1 through 2.1, 1 and 9/10 to 1 point. And I have that on the graph. So we're going to do second key, and we're going to hit the trace key. And we say it as second calc because it's the second key will get what's blue on the top. All right, so let me do this, the second key and calc, because that's what you want to match as what we want to do work on. So let me get back to my pen here. So I'm going to do second calc, and I'm going to hit number 1. I enter. And now it's a flashing cursor beneath the graph. And now I enter the values I need. Right. So those are our notes, and we're going to now do the table. I'm going to enter 1.9, and I'm going to get 9.41. 1.99 and enter, and I'm going to get 9.9401. Now I'm going to put the 1.99 and enter. That's the one I just did, sorry. 1.999 because we're getting closer and closer to that 2. And I get 9.994001. 2.001, which we're not doing the 2 because at 2 it is undefined. It's a removable point. So here at 2.2 I get 10.0001. Oh, I forgot a 6 in there. Sorry about that. 601. I apologize. My eyeballs. So now I'm going to do 2.01. It's getting further away from 2 as the decimal places are reduced. And I get 10.0601, getting a little bit larger in value, to 2.1, and I'm getting 10.61. All right, so what we're looking at is what is the limit? Sorry, let me undo that. But what I needed, I apologize, was the values between 199 and 2. And we can see that that limit is 10. 10 lies very close to both. All right. So the limit as x approaches 2 for f of x is 10. Now, what happens with it as we look at it? I can do second count value at 2, and it is what? No response because it's an open hole. And what that means is that it's factorable, that the function is factorable. So if I have f of x equals to x cubed, x cubed minus 2x minus 4 over minus 2, then what it says is if I do x minus 2 into x cubed minus 2x minus 4, x will go in there, x squared times x cubed minus 2x squared. I draw my line, and I'm going to change my signs. This is negative and this is positive. This zeroes out, so I bring down my positive 2x squared minus 2x. And so that's going to give me, sorry, that's real thick. That's going to give me a positive 2x. So that'll give me 2x squared minus 4x. All right. Draw my line and change all signs. And when this'll zero out, and I'm left with negative 2x minus 4. So I'm going to have a negative 2, and that'll give me a negative 2x minus 4. When I draw my line and change my signs, I end up with no remainder. So, yes, I would have this. And if I reduced it to that and I put in a 2 in there, I'm going to end up with 10. There you go. So let's look at another one. And we'll discuss a little bit about what we are doing. The function f of x is a polynomial. Okay, because it's a polynomial, it is continuous, or domain of x. That means that there isn't an x it does not have a value for, and it is a curvature, because this is a parabola, and so there's no place it is undefined. So therefore, the limit is to drop it in. Three. So we don't have to do the limit from the left or the limit from the right. We can just drop it in. So we want f of 3. And that'll give us 2, 3 minus 4 times the 3 plus the 5. This times 9 minus 12 plus 5. 18 minus 12 is 6. And 5 makes it 11. So the limit as x approaches 3 for this f of x is 11, because it's a polynomial. There's no break in the line. All right. And you could have put it in and dropped it in. Now here we have a rational function. So we need to be careful with a rational function. So we want to check. It is factorable. So the denominator is x squared plus 5x plus 4, and we want to factor. So I'm going to have x minus 4 times x minus 1 to get the, oh, and it's positive, sorry about that. It's plus. All right. So I can see that it is undefined at x equals negative 4 and x equals negative 1. But they want x of 3. So now that I have found the restrictions to domain, and 3 lies, negative 3 lies in this vicinity here, and it is in the domain, we can drop it in. We can drop it in. So we're going to take the limit. So this means I'm going to have a negative 3 and a negative 3 over negative 3 squared plus 5 times that negative 3 plus 4. That's a negative 6 in my numerator. I'm going to have a positive 9 minus 15 plus 4. Okay, well, we're going to have 13. Well, we're going to have negative 6 plus 4 is a negative 2. So my limit, sorry, I didn't bring it forward. So my limit as x approaches negative 3 for this f of x is, and that's a positive 3. And notice that we used all the tools of algebra to figure out the domain of the variable to figure out if something exists, that we can drop it in. Now on this one, we have another rational function, and we know that x cannot equal negative 2 because then we're dividing by 0. So they want the limit as it goes to a negative 2. All right, so now we have to determine, because we know we're going to have 0 here, and if I put in a negative 2, I'm going to have a 4 plus 2 minus 6, so it's a 0 over 0. And later on in calculus, we call it the L'Hopital rule, but in this case, we're going to use algebra. All right, so that means we're going to factor the numerator this time. So if I have x squared minus x minus 6, it factors to x plus 2, x minus 3. So this will give us the negative 6x, and this will give you a 2x, so the difference is a negative x. So now we have the factors. So this means that I can cancel this out and take the limit as x approaches negative 2. Well, that would make it a negative 5. Well, we can also do it with the calculator because we talked about that anyway. So let's go to our y equals. We can clear that out, and we're putting the original function. So whichever way you want to go, it's okay. Ax squared minus x minus 6, close parenthesis. I opened it to begin with, close it, divided by, and I'm opening it again as x plus 2. Parenthesis and graph. And it looks like a straight line. So we can do second calc value. We want f, and we want it smaller than that. So we can put 1.9. Oh, okay, and I'm getting 1.1. And then I can do f of 1.99. 1.99. And enter, and I'm going to get and that was a negative, sorry about that. Negative 1.01. And then I'm going to do 1.999, very close to 2, and I get a negative 1.001. So now I'm going to put f of x Sorry about that. F of 2.001. So I'm going to put 2.001. And it exists at 0, negative 0.999. So we can see then that it is, the limit is -1. I must have done a math error here. Let's see what I did. Oh, it was a -2. I apologize. I got the wrong numbers here. These are all negative. We're going to be positive. I apologize. Bad math here. Sorry. And it's all right. We got a calculator. So I'm going to do negative 1.9, negative 4.9. Right. So I'm going to do the negative 199. Again, negative 4.99. And this is 39. Sorry about that. And a negative. Negative 1.999. And I get negative 999 for negative 4 and 3 nines. I'm going to do negative 2.1231 or 21 there. And I'm going to get what? Negative 5.001. I'm not going to go through the whole mess because we know it is in between those two, and that is a -5. All right, I'm going to stop right there, and we'll continue on when we get back.